Over this series, we've built something genuinely powerful, an agent that can reason, use tools to act in the world, remember you across time, plan complex tasks, and even coordinate a whole team of other agents. That's a lot of capability, and here's the uncomfortable truth. Everything that makes it powerful is exactly what makes it dangerous. Think about what this thing can actually do now. It can send emails on its own, move money between accounts, delete files, read through your private data, act on instructions hidden inside a web page it happens to stumble across. A capable agent turned loose with no limits isn't just a helpful assistant anymore. It's a serious liability, one confident mistake or one clever manipulation away from doing real and sometimes irreversible harm. And you can't just trust it to behave, not because the model is malicious, but because it can be wrong, it can be confidently mistaken, and it can be actively manipulated by bad input. Hoping an autonomous system with real-world powers simply does the right thing every time is not a safety strategy. It's a gamble. So we build it a safety system, a set of checks and limits that sit around the agent, watching what goes in, what comes out, and what it's about to do, ready to step in the moment something looks wrong. These are guardrails, and they are what make it safe to give an AI real power. This is the guardrails ring from my video on agentic design, the red boundary that wrapped the whole system. Today we open it up, where guardrails sit, what they catch, and how they keep a powerful agent safe, on task, and under control. Let's build it piece by piece. Part 1. What guardrails are. At their simplest, guardrails are a layer of safety checks that surround the agent. The agent does its thinking in the middle. The guardrails form a protective boundary around it, inspecting everything that crosses in or out. Their job is to catch the things that should never happen, a dangerous request slipping in, a harmful response going out, a risky action about to fire. When a guardrail spots one of these, it can block it, rewrite it, ask a human, or stop the agent entirely. It's the difference between an agent that merely tries to be safe and a system that is kept safe. This is the guardrails ring from my agentic AI video. Remember how it was drawn in red, wrapping around every other component, the model, the tools, the memory, all of it. That was on purpose. Guardrails don't live inside any one part. They surround the whole thing because a threat can come from anywhere. Think of a power tool. The blade is the capability, the part that does the actual work, but no responsible tool has just an exposed blade. It has guards, safety switches, and automatic brake. Those don't make the tool weaker, they make it usable. Guardrails are the safety housing around a very sharp, very fast AI. So guardrails wrap the agent and inspect everything crossing the boundary. But hang on, we already gave the agent rules back in the instructions video. Isn't that enough? It turns out it really isn't. And understanding why is the heart of this whole topic. Part 2. Why asking isn't enough. Back in the system prompts video, we gave the model rules. Never do this, always do that. So a fair question is, if we already told it how to behave, why do we need a separate safety layer at all? Here's the key distinction. Instructions ask the model to behave, guardrails enforce that it does, and that gap between asking and enforcing is everything. Instructions are a request written inside the model's own context. The model reads them and mostly follows them. But mostly is a terrifying word when the tool can wire money. Because a model can be talked out of its instructions. A clever jailbreak, a prompt injection hidden in a document from our system prompts video, a strange edge case the instructions never imagined. Under the right pressure, the model can be convinced to ignore its own rules. Live inside the mind you're trying to control. That's their fundamental weakness. There's a way to feel the problem. Imagine you hire a brilliant, eager employee and tell them firmly, never wire money to an outside account. Most days, fine. But then someone sends a very convincing email, impersonating the CEO with an urgent story, and the eager employee, trying to be helpful, does it anyway. The instruction was never enough on its own. What you actually wanted was a second system, a bank that simply won't allow the transfer without separate approval. That bank is a guardrail. Guardrails fix this by living outside the model. They're separate code and separate checks that the model cannot argue with or be tricked into disabling. No matter what the model decides to do, the guardrail still runs independently and can still say no. It's the principle of trust but verify. Let the model try, but check its work with something it can't talk its way past. So instructions are the model's good intentions, and guardrails are the enforcement that doesn't depend on them. Now, where exactly does that enforcement happen? There are three critical checkpoints. The three checkpoints. Information flows through an agent in a simple path. Something comes in, the model thinks, and something goes out, sometimes as an action. And there are three natural places to put a guard along that path. First, at the entrance, input guardrails, which check what's coming in before the model ever sees it. Second, at the exit, output guardrails, which check what the model produced before it reaches you. And third, and most important for an agent, right before any action. Guardrails, which check what the agent is about to do before it actually does it. Picture the flow: input guard, model thinks, output guard, and whenever it reaches for a tool, another guard right on the trigger. Three gates at the three moments where things can go wrong. Nothing dangerous gets in, out, or done without passing a check. Three checkpoints: input, output, and action. Let's walk through each one and see exactly what it's watching for. We'll start at the front door. 4. Guarding the input. The first checkpoint sits at the entrance, inspecting every request before it reaches the model. Think of it as a bouncer at the door, deciding what's even allowed to come in. And it's watching for several distinct things at once. Prompt injections and jailbreaks, those attempts to hijack the agent that we met back in the instructions video. Requests that are simply off-topic or abusive, that the agent has no business engaging with in the first place. And sensitive information, a customer accidentally pasting a credit card number or a password, that should be detected and stripped out before it's ever stored, logged, or fed into the model at all. Why stop it at the door? Because the cheapest, safest problem to handle is the one that never gets in. If you can recognize a malicious or nonsensical request up front, you can refuse it immediately, before the model spends any effort on it, and long before it could act on it. Catching trouble early is always easier than cleaning it up later. So the input guard filters what comes in, but even a perfectly clean request can lead a model to produce something it shouldn't, so we need a check on the way out too. Part 5. Guarding the output. The second checkpoint sits at the exit, inspecting what the model produced before a single word of it reaches the user. If the input guard is a bouncer, this one is an editor, reviewing the work before it's published. And it catches a completely different set of problems than the input guard did. Harmful or toxic content that somehow slipped through the model. Secrets or private data it shouldn't be revealing, another user's information, an internal system detail, or even its own confidential instructions. Claims that look invented or unverified, the hallucinations we've worried about all series now caught on the way out. And answers in the wrong shape or format that would quietly break whatever system is waiting to receive them. When the output guard catches something, it has options. It can block the response entirely and return a safe fallback. It can redact just the bad part, like masking a leaked phone number. Or it can send the whole thing back to the model and say, try again, this violated a rule. The user only ever sees output that has already passed inspection. So we guard what comes in and what goes out. But for an agent, the most dangerous moment isn't saying something wrong, it's doing something wrong, and that needs the strongest guard of all. 6. Guarding the actions. This is the one that matters most for a true agent, and it comes straight from a warning. The tools video. Remember the difference between reading the world and changing it. Action guardrails live right on that trigger, checking every real-world action before it happens. The simplest form is permissions. Just because the agent can call a tool doesn't mean it's allowed to right now for this. This agent may read the database but never delete from it. It may draft an email but not send to anyone outside the company. It may spend up to $20 but not a cent more. Hard limits enforced in code that the model simply cannot exceed. And for the very highest stakes actions, the guardrail isn't code at all, it's a human being. This is the human-in-the-loop pattern we first saw with tools. Before the agent sends that particular message or makes that payment or deletes that record, it has to stop or present exactly what it intends to do and wait for a person to approve it. The agent proposes the action. A human, understanding the consequences, actually pulls the trigger. For anything truly irreversible, that one deliberate pause is worth more than any amount of clever programming. This is what makes real autonomy safe. An agent with powerful right tools and no action guardrails is genuinely reckless. But wrap each dangerous action in a permission check, a spending limit, or a human approval, and you can hand the same agent real power without handing it the keys to cause real damage. The capability stays. The recklessness is fenced off. Input-output actions, 3 checkpoints, each watching for its own kinds of trouble. But what actually does the watching? How does a guardrail decide in the moment whether something is safe? Part 7. How guardrails actually work. A guardrail has to make a judgment, safe or not safe, quickly and reliably. And there are 2 main ways it does that, often working together. The first is simple rules and filters, fast deterministic checks written in plain code. Does this text contain a credit card number? Is this action on the ban list? Does the output match the required format? These are cheap, instant, and completely predictable. For clear-cut cases, a simple rule is perfect, and you should always prefer it. But some things are too subtle for a rigid rule. Is this response actually toxic or just blunt? Is this request a real jailbreak attempt or an innocent question that happens to sound suspicious? For these, we use a second AI as a judge. A separate model whose only job is to look at the input or the output and rule on whether it's safe. A model checking another model. There's something almost paradoxical about that, worth pausing on. We spent this whole series learning that models can be wrong, so why trust one to police another? The answer is that the judge has a far narrower, easier job. It isn't trying to solve your task. It's only answering one small, focused question: is this safe, yes or no? A specialized check like that is far more reliable than the open-ended reasoning it's watching over. And crucially, it fails differently than the main model, so the 2 rarely make the same mistake at the same time. And you don't pick one, you layer them. Fast rules catch the obvious cases cheaply. An AI judge handles the subtle ones. Permission checks stand guard on the actions. This is defense in depth, many independent layers, so that if one misses a threat, another still catches it. No single point of failure, because in safety, one line of defense is never enough. So guardrails combine fast rules, smart judges, and hard limits. In overlapping layers, it sounds like you just want as many and as strict as possible. But that instinct, taken too far, quietly breaks the whole agent. Part 8. The central tension. Guardrails live on a knife's edge between 2 failures, and every real system has to find its balance on that edge because you cannot fully escape it. On one side, too loose, weak guardrails let real threats through. A jailbreak succeeds, private data leaks, a harmful action fires. This is the failure everyone worries about, the dangerous one. So the natural reaction is to crank the guardrails up and make them stricter and stricter. But there's a failure on the other side, too, and it's sneakier, too strict. Guardrails so aggressive they start blocking perfectly good, safe things. The agent refuses reasonable requests, it second-guesses harmless actions. It becomes so cautious it's exhausting or useless. An assistant that won't help you out of an abundance of caution has its own kind of failure. This is the balance between 2 mistakes, a false negative, letting something bad through, the dangerous error, and a false positive, blocking something good, the annoying, trust-eroding error. Push all the way toward safety, and you get a useless agent. All the way toward capability, and you get a reckless one. The art is in the calibration. And where you set that dial depends entirely on the stakes involved. An agent that can only read public information can afford to be fairly relaxed. The worst case is mild. But an agent that can move money or touch medical records or email your customers should be locked down tight and made to ask permission constantly. The rule is simple to say, and it ties this whole video together. Match the strictness of the guardrails to the real cost of a mistake. Low stakes, light touch, high stakes, lock it down. Powerful enough to be useful, guarded enough to be safe, and calibrated to the stakes. We've built the whole system. Let's step back and see the complete picture. So here are guardrails whole, a layer of safety that surrounds the agent, enforcing limits from outside the model where it can't argue with them. At the entrance, input guards filter what comes in. At the exit, output guards inspect what goes out. On every action, the strongest guards of all check what the agent is about to do. Fast rules, AI judges, and hard limits layered into defense in depth. And this is the piece that makes everything else in this series safe to use. All that capability we built, the tools, the memory, the autonomy, the teams, only become something you can actually deploy in the real world and with real stakes because guardrails keep it fenced. Guardrails aren't what make an agent smart, they're what make a smart agent trustworthy. And here's the idea to carry away. Safety isn't a feature you sprinkle on a finished agent at the end. It's a boundary you build around it from the start. The most capable AI in the world is useless, even harmful, if you can't trust it to operate within limits. Guardrails are how you earn that trust, not by hoping the model behaves, but by making sure it can't do otherwise. Give a powerful agent firm external limits calibrated to what's really at stake, and you get something rare. Real capability that you can actually trust with real responsibility. If this made guardrails click, give it a like, it really helps the channel. And subscribe because next is the finale of this series, evals and observability, how we actually measure whether any of this is working and keep watching it once it's live. We're building AI up from the ground, one blueprint at a time. Thanks for building it with me. See you in the next one.